Hello everyone, my name is Yuto Hori from JGC Corporation. Thank you for joining this breakout session today, and I would like to present you Be Digital and Transparent with Cutting-Edge Project Execution Platform. So for this breakout session, I would like to introduce some important points of being digital and having transparency in mind on AWP management. Also, I would like to explain the key points when implementing the constraint management for AWP management successful. The concept actually have been developed through many discussions and workshops in the JGC internal discussion with the engineers and lead engineers and project management team. So all of the concept that we're explaining about this session are based on those workshops. And also, we implemented our in-house project execution platform that is based on this constraint management and AWP methodology. So I will introduce you with some video of demonstration of how we implemented this into our in-house platform. And today's contents, I will introduce myself and about the JGC Corporation. And I will do some quick recap from previous conference that we joined in 2019 and 2021. In previous sessions, we explained a little more general about our AWP methodology in JGC way. So I'd like to go into deeper and more detail in this session. In the second part, I will explain the being digital and having transparency in mind is important in AWP. First, starting with digital, and also, and second part is transparency in constraint management. And third part is a little bit more detail about the constraint management. I will point out some keys when considering constraint management. And also we'll show you a video of demonstration of how JGC implemented this the points of constraint management and being digital into our in-house project execution platform. And then I'll close with summary. Please enjoy. Start with the introduction of myself. My name is Yuto Hori. I joined JGC in 2012, and that time I joined the project for preparing the project master schedule using P6 Primavera software. And also during the execution stage, I monitored the project progress for reporting. And then I moved to process engineer for basics design. And during that time, I was involved in one of the LNG project doing development and optimization of overall plant safety relief system. And then I moved to the current department for developing, doing the system definition of AWP management system. And I really think that the previous two experience in different departments are actually really helping when doing the system development work for AWP management system, because during that time I was really hard time to find out where the constraints are and how that constraints are impact to all the subsequent activities. So that is becoming like my motivation toward developing this system. About our company. The JGC was established in 1928, almost 90 years ago, and we have approximately 9,000 employees all over the world. And our core business is EPC business, so that we do engineering, procurement, construction and maintenance for various plants and facilities. And also we do manufacturing of functional materials such as fine ceramics and some catalyst and so on. And here, these are the business areas. We have three main parts. One is EPC business, second one is manufacturing, and the third one is consulting. For EPC business portion, in energy transition part, we involved in the project of LNG plant, refinery plants, and also renewable energy and the nuclear power plants and so on. And for infrastructure, we joined the project of transportation infrastructure such as railways or airports, and also we do agriculture project and water treatment and so on. And for healthcare and life science, we design and build hospitals in Japan and also overseas, and also designing and construction of the industry for example, producing medicines. And the resource recycling, we do have a project of gasification and chemical recycling of waste plastic and fibers. And with Japanese government and some other Japanese companies, we do proceed the promotion of next-gen sustainable aviation fuel, as known as SAF, using the used cooking oil as well. For manufacturing portion, we do have a unique sales of the catalysts and fine chemicals, and also the fine ceramics too. And last, for the consulting portion, we do have information research and also do the consulting regarding energy and environment, and also some numerical analysis simulation in this field. And that's about it for my introduction of myself and the company. Let me quickly recap from previous AWP conference. In last conference, I introduced to the EWP methodology that JGC thinks about, and also how does the AWP can be optimized throughout the EPC process. And for today's conference, I would like to go into more detail about the constraint management. So this is a recap from previous session. The last time I talked about the project going to break down into EWPs, PWPs, and CWPs. And here we talk about EWPs such as their types are documents, drawings, vendor information, list, calculation, 3D model, and so on. And also for PWP, program and work package, we believe there are activities such as requisition issuance or technical bid evaluation. And for construction activities are at site is known as CWP. So in the last session, I emphasized that the all work package should be defined, and also these work packages should be connected each other so that there are multiple passes are defined and shown, and unless otherwise the constraint management cannot be really achieved. That was the key point from previous session. Also, for doing the AWP optimization overall, I presented the importance of continuous feedback of priorities and required date, and that should be grouped from successor to predecessor and going back to successor again. So here's this example. We have a CWP and IWP and successor. And for the predecessors, there are engineering, procurement, and construction work packages. And information or material and work areas is handed to successors as such. So the feedback of priorities and required date is start from setting the construction sequence from CWP or IWP. So that's from successor. And that priorities or construction required date, that when you need the date, is feedback to predecessor for the constraint release requirement. And predecessor will do the sorting and changing the sequence based on the CRD and priorities. And that is feedback to successor again to optimize the schedule. And the group is going back from successor to predecessor and predecessor to successor. So this loop is really required for the constraint management and overall AWP optimization. And this is not only happening in construction and engineering. what I just explained was this portion only, but we are trying to proceed that to optimizing engineering and procurement. So it used to be there's a connection from engineering to construction, procurement to construction to construction only, but it should be expanded to optimization of engineering to engineering and also engineering to procurement and procurement to procurement. So after achieving these loops inside each phases and between phases, then finally overall optimization of EPC can be also achieved. So those were the key points that I have discussed in previous session. And for today's session, I would like to go into deeper about how this constraint management, after setting all the relationship between activities, are achieved by having time in engineers so that management can. So can you imagine what happened without being digital on AWP? Please think about it for a moment. And then this actually happening in our company, and I can and they're connecting that from emails or phone calls or sending the Excels back and forth. And if this has happened, there will be a discrepancy between the disciplines for sure, and there will be endless communication to who has the what kind of priority and what kind of dates. So be confused. And also, after sharing the information between the disciplines, they also have to report the progress to project management team. So there will be many Excels or emails, phone calls sent to project management team, and also project management team will receive many Excels to summarize the report. So there will be high managing costs. So this manual update and also for the time for summarizing report is also wasting the really many man hours. And at last, the project manager or engineering manager positions, he or she cannot really point out who has the bottleneck if this information is available everywhere, so that he or she cannot get the real-time info and having really difficult to have a quick decision on how to resolve the bottleneck. So digital in AWP, why digital? I came up with these 5 factors are really important considering the digital in AWP. First one is online. So once data is available, then all activities should be stored in one location so that everyone can refer to the same information at the same time. And all the connections should be available online too. And once all the data are stored in one location, then it should be synced with other systems and the data should be automatically updated. So for example, once activities data is on server, then if that data is synced to engineering management document management system, the document management system should send the latest information or schedule to the platform automatically every day, so that the engineer doesn't need to go into 2 systems to find the latest status of one document. And having sync with other systems or online are not enough. this should be available at real time, so that, for example, a manager side or the project management team can track the latest status at all the time. So that is a good part of the having real time too. And also, once the platform is available, then regular maintenance and upgrade or continuous improvement should be conducted too. So for example, our project execution platform has always getting the feedback from the users and trying to implement that or new function or bug fixes instantly, so that there will be no stop or bother during the job execution. And the last part is transformation. So after this platform is available, then platform has really huge power on changing the current project execution way, so that the users and also developers should think how to transform even like a current project management method based on this platform. So you need to think about how to transform the methodology or how to conduct the project management all the time. So these are the 5 factors thinking being digital on AWP is really important. Second part is transparency in constraint management. So why transparency is important? Once all the data are stored in one location and those relationships are available, then anybody can look at what is the status or the progress or where the constraints are. Those are revealed and recognized by all the stakeholders. And why that is good? Because so that once the constraint is available, then everyone can look into the focus on the constraint and trying to resolve in one team. So that's why transparency is really important in considering AWP management. And this is an example of how you can see the transparency on the constraint management. Please imagine that you are the construction engineer who has the piping IWP installation work package and the foundation installation work package, and you realize that there is no information is available for starting his or her work. And then you trying to go look into why you cannot start your IWP installation work package. Then you realize that these isometric drawings are not yet issued, or the foundation drawings are not yet issued. And you're trying to figure out why those informations are not available. Then you realize that there are some comments from model review is not yet available, or the document from any equipment general arrangement is not yet issued, or steel structure drawings are not yet issued, or the valve drawings are not yet issued. And then you will try to find further before to go to the predecessor and find out that for the drawing issue, the information is still not yet available. You're going further, and we realize that the equipment general arrangement drawings are not yet prepared. So as you can see, all the activities are connected in chain, and there are many various ways of connecting the activity, and there's a predecessor and successors. So once I pointed out that all the activities should be defined and connected as this kind of relationship, and once it's available in one location, then anybody can see and what is the constraint, or where does the information stop at any time. So this is the portion of that I explained about being digital is important, so that everybody can see the status, and also transparency is important so that anybody can track what's the latest status. Find out where the constraint is. And third part, I would like to go into more detail about how the constraint management, what is the constraint management, and like how to implement into the platform. So I'd like to start with the key points on the constraint management. So first, please imagine like what happens if there's no monitoring of status. So here's our answers. If there's no monitoring of status, there will be no committed issue date. So there will be endless updates of the forecast date from predecessors. And if you are the one receiving the information, you always been say that you say tomorrow like yesterday. That happens all the time. So if that happens, then we cannot see how much of that delay will transfer to subsequent activities. And there will be the construction activities at the very end, and they are always the one trying to absorb all the delays that happen in upstream engineering work. And that always happens, and we're trying to avoid it. And here, I will explain what constraint is in the constraint management. So there are 4 engineering work packages, 3 in predecessors and 1 in successor. So these 1 and 2 and 3 engineering work packages are input into number 4 AWP. And if these are the 3 information you need for conducting AWP number 4, then you will set the required date to predecessor work so that you want to know like by what date you want the previous or predecessor's information. And once you set the required date, there will be the forecast issue date from predecessors when you can probably issue the information. And as you can see, number 1 and 2 are okay prior to the required date, so there will be no problem. But number 3, the activity is the problem because the forecast issue date is beyond the required date, so this will be the constraint. And if this constraint happens and accumulates, then there will be delaying of the successor work, and then that accumulates to all the way down to construction work. So that was what is the constraint. And next I'll talk about why constraint management is needed. So this slide I show you in the previous slides that the project is now being divided into all work packages and how important that is to connect all the activities to see where the constraints are. And there are many different paths or paths of activities that are existing, and you have to realize what kind of paths are available in the EPC project. So for example, there are like simplest one is that there's an engineering work package, procurement work package to the construction work package. There are more complex one that there will be the engineering work package between the procurement and the construction. The example is that once you have the purchase order, then the vendor will design the work package, and then the design will feed back to engineering work package, for example, for like 3D model and so on. And the information will then transfer to CW construction work package. The last example is there's no procurement work package in between. So there is an example of, for example, civils, shore or drainage design that engineering design work package information is directly going to send to CWP. So there are multiple paths available, and you need to understand that there are various types of paths in EPC project, and that needs to be connected to define where the constraints are. Then next one is what is necessary for the constraint management. And then I summarize into three. We believe needed for validation, date, and mindset. So as I shown on the previous slides, the relationship between work packages are really important so that anybody can see how the activities are connected. And once the connected are seen, then you can figure out how that one delay caused the impact to all the subsequent activities. And also the required date from successor. As I explained, also know what happened if there's no more status. So you have to have a committed date and also required date from successor, and see if there's any gap between those activities, so that we can simulate the impact to the subsequent activities. And also the mindset. So this is the same as the transparency, that the people needs to think about and have a mind that they're being part of the constraint management, being part of the chain of the activities, so that everyone will have need to update the forecast date in real time. So all the management team and successors activities person in charge can know what the latest status. So these three things are really needed to make the constraint management possible. So next is how to implement the constraint management. And that the answer is the being digital and having the transparency mindset is really important. So activity status should be in one location so that everyone can see the latest and same information at anywhere with real time. And connections between the activities are important so that the constraint management can be possible. And also, once these three above informations are available, then visualizing relationships is really important too, so that people can see what the flow looks like and how does the relationships are considered in the constraint management. The last portion is also important because setting up the relationships is not enough. It should be able to simulate the impact so that how that constraint affects to all the subsequent activities. And I will show you these two parts in the last part of how JGC implemented in our in-house project execution platform. So just to summarize the key points of the constraint management, that it's really important to understand the making connections to establish it throughout the EPC and know what is needed for the constraint management, like all the connections, required date, and the data should be stored in one location, and also the mindset. And the last, the implement how constraints be found and controlled by being digital and transparent. This is by everyone should have the same mindset, and also all the data of activities should be stored in one location and synced with like other systems so that anybody can see the latest information anywhere. Okay, for the second part or third session, I'd like to show you some JGC's implementation. So this is the same diagram that I showed you before, that without like digital in mind, this is what's happening, and this is what happened. We're trying to change this situation by having the centralized database for activity management, so that anybody can refer to the latest information in the same data by anywhere. Also, once this database is set up, then of course the data inside can be updated automatically by syncing with other systems, for example, like document management system or 3D model, and so on. So that once this is available, all the discipline engineer don't need to do any additional reporting, and also project management side can only check once in the system so that they don't have to receive all the Excel sheets to summarizing the report. So there will be less manpower for conducting those reporting work. Last, for the project management and engineering management position, they can find the constraint much easier by visualizing a constraint, so that they don't have to spend time to find where bottlenecks are, but they can know it instantly through just seeing the simulation function. And they can spend more time on how to resolve the constraint and rather not where to find where the constraints. So based on this idea concept, we developed the system called the J-Driven. J-Driven is a JGC-driven project that we like to drive engineering and the whole project with all stakeholders. And this is the promotion video that we created, so please enjoy.
Let us introduce the outline of the system named J-Driven for promoting AWP. J-Driven is an in-house developed system designed to find and resolve bottleneck in the execution of EPC projects. Project management of the larger EPC project is becoming very complex. It takes time to check and exchange the work status between engineering teams by emails or phone calls. When the schedule is getting delayed, it's difficult to find out what exactly constraints are and how far the impact of delay will propagate to subsequent activities. It's time-consuming for project management or project control team to gather the latest status every time from all engineering teams. For engineering teams, also it's extra hours to report for project management team. That's why J-Driven was created. J-Driven is a common platform based on the AWP methodology that allows everyone to manage the work schedule of the project. With J-Driven, you can reduce coordination and reporting tasks for work management. With J-Driven, you can get the latest work status in real time and take actions on delays at the right time. In J-Driven, each activity is created as a work package. And by connecting activities and creating workflow, and setting the required date of predecessor's work package, the constraint of the work package can be visualized. J-Driven connects with other JGC systems in order to share latest information between systems and avoid discrepancies. Then you can get accurate information from J-Driven. Connecting with document control system to download the latest document information once a day in batches at night. From schedule control and management tool, control level schedule and critical path can be obtained. Excel control sheet used in team or personal can be also imported to J-Driven. The imported contents can be edited on J-Driven and exported from J-Driven. And in near future, we plan to further connect with other systems such as construction management system, engineering management system, and correspondence system, and so on.
That was about the promotion of the J-Driven system, and I'd like to add some explanation of what kind of functions that J-Driven has. So this system can generally able to do the work package setting inside the system, so that you can create the many different kinds of the work package, and also connecting work package between, and setting the required date from successor to predecessors. So this is the example that you can define all different kinds of For example, this is the engineering work package, so that you can have equipment loading data work, and also instrument control valve information settings, and you can connect the activity to, for example, to 3D layout of one area. And you can also input the status of each activity, so that if this is completed or incompleted too. And you can set the required date to all the predecessor activities. Also, this system has interference with other systems, so that it can collect information of, for example, latest document schedule, or what kind of documents will be issued, and also other procurement and construction management system to have the latest information as well. Also, this system has a monitoring function. Say you can visualize all the connections that have been created before, and also do the simulation of how one delays impact to all the successors activities. And if there are any activities that is behind the ERD, there will be alert function is also implemented, so that the person in charge can realize if that activity is delayed or not. Also, some additional explanation about the system configuration of J-driven. So right now there are these engineering, procurement, and construction system, document management system, and P6 schedule communication systems around J-driven. And these information can be transferred or synced using the tag information to get the data from other management system. Also, it has a correlation between the P6 schedule, so that you can have a consistency check with P6 schedule if the management that schedule is matched with the P6 schedule. Also has this communication system, like correspondence system, that management system. This kind of information can be correlated to the J-driven too. So here I would like to show you some demonstration of J-driven. First, with the constraint management, and in this video, you can see the connections between the activities, and also by setting the required date from successor to predecessors. And in this flow diagram, you can also check the schedule date for each activity, and so that you can see all the activity status at a glance. All right, let's begin. So this is the flow screen on the J-driven. You will select one activity here, the structure information as an example, and it will pop up on the function diagram, and this one box is the work package, and it has the package number and also like what kind of this screen the activity has. If I expand that to the successor, then you can see the required date, but what kind of dates that the information is required from successor. And here you can expand even more the drawings, then you will have construction work package in successor side, and that will be the end of the pass. And then now you will use predecessors, find the required date and 3D model layout before the information. And for 3D layout, you need a pump vendor information or P&ID information and control valve type selection. And you can see the required date and also the plan and the forecast date for each activity too. And I can keep expanding to all the predecessors work and you can see the activities in predecessors. And also you may realize there are three different colors in box. The blue shows the activities are not yet completed, and the gray ones are the ones completed. And also the orange ones are the activity that is on the critical path. So as you can see from at the glance, you can instantly know what kind of activities are connected to predecessor and the status of each activity by different colors too. And you can move around each work package as you want. And also you can zoom out to see whole view of the management, how the chains are connected. And also zoom in to see each activity status. So that is the first part, the flow diagram. And on the second part of the demonstration, I'd like to show you how this simulation function works. So as I explained in the slides, that simulation is really important to see how one constraint can be impact to subsequent activities. So in this simulation, you can set the expected forecast date, not the real forecast date, so that anybody can do many times of simulation as they want, and also changing the required date to say real date, like what should be the expected, what should be the impact, and what should be the fixed real required date too. And you can see how much of delay will propagate to subsequent activities by delaying one activity. So here's a demonstration. So let's start from flow diagram, and then I switch to simulation mode. And you can see the same path that I show you before, and say, for example, pump vendor information. I try to set expected forecast date. Current is October, but I set it to April this year and hit simulate. Then instantly, like, you realize that since expected forecast date is delaying later than the required date, there will be the delay sign. So there is a gap between forecast and required date, and that gap will be transferred to subsequent activities. So there's will be new forecast date for each activity, and you can see all the delays are propagating to the subsequent activities, and you can see that the delays are now at the construction work package 2, and their expected forecast date will be delayed too. So this is how we can simulate the one constraint delay to all the way down to construction work package. And we think this is really important to see that, so that everyone can do their own simulation, and all the project management teams can do to see how does one delay impact to all the way down to the downstream. By this, you can set the new required date or the new forecast date, or maybe changing the sequence to find out the constraint in advance, so that everyone can tackle to resolve the constraint in productive way. And that's all about the demonstration of J-driven. And I would like to close my presentation with the summary. So success in AWP management, you need to have a consideration of realizing the constraint management. You need to have all the connections are set, and the required dates are set from predecessor to successor to predecessor, and so on. And to success or to achieve the constraint management, you need to have a digital in the AWP management, and also with the mindset of transparency. Unless the constraint management cannot be achieved, and also the AWP itself cannot be achieved too. So you need to have these are in mind when you're setting in the platform to achieve the success in the AWP management. And that's all about my presentation. Thank you very much for listening, and enjoy the rest of the breakout session. Bye.